Pour crushed ore or ash down a steel chute for a few weeks and the metal thins, grooves, and wears through. The rock is simply harder than the liner protecting it. The dark plates laid out here flip that contest. Sintered from silicon carbide, a surface so hard the abrasive sliding across it can barely leave a mark. Open with hardness above 2200 on the Vickers scale, near 9.5 on the 10-point Mohs scale, second only to a handful of materials like diamond. It carries that hardness at well under half the weight of steel, and with a stiffness over 400 gigapascals it stays rigid under load instead of flexing into wear. Heat barely troubles it. Silicon carbide carries warmth like a metal. A thermal conductivity above 120 watts per meter Kelvin. And its low expansion lets it shrug off swings over 250 degrees without cracking. Acids, alkalis, and slurry leave it unmarked across the full pH range, and it holds its strength past 1000 degrees in air. The reason it lasts comes down to a contest of hardness. Abrasive wear turns sharp once the grit is harder than the surface it slides on. Below that line the particles cut and plow, above it they skate. Most mineral grit, quartz and sand, sits near 7 on the Mohs scale. Silicon carbide sits near 9.5, well above it, so the abrasive that grooves steel cannot find purchase here. Push that advantage into numbers and the wear rate falls below 1/10 of a cubic millimeter per 1,000 cycles. A loss so slow that a lining measured in millimeters outlasts a steel one many times over, holding its profile while the flow keeps coming. Dimensions start from the surface being protected. Tiles run in familiar squares, from around 50 millimeters to 150 on a side. In thicknesses of roughly 5 to 25 millimeters, sized so an array tessellates across a chute or a cyclone wall with minimal gaps for where to start. Past the standard squares, the format follows the duty. Custom shapes that nest on curves, radiused tiles for cyclones, mounting holes, weld stud dimples, and beveled edges are cut to the structure and the wear pattern. Each plate ground to a drawing rather than a catalog size. The duty that suits these plates best is wear lining. The chutes, hoppers, and cyclones where crushed mineral slides past day and night and tears ordinary steel apart. Bonded across a transfer chute or a cyclone cone, the tiles take the brunt of the sliding load. The near diamond face shrugs off the quartz and ore that grooves steel. The slick surface lets material slide rather than pack and bridge, and because each tile barely wears, the lining keeps its profile and the flow path stays true. Changeouts stretch from weeks to long intervals, and the structure underneath stays protected the whole time.